Is the sound good? Okay, I think we can start with some questions while more people joining us. So if you have any questions prior to the topic about Kotlin in general. Actually, who uses Kotlin now? Okay, so you know about Kotlin. Who read about coroutines? At least something. Okay, have you used it already, coroutines? Who has? And what about the others? You've read about it, but you may be afraid of experimental status, or? You're still on the RxJava and you don't see what coroutines bring. Not yet. Okay. Yeah, exactly like. Why do we need coroutines if we have RxJava? Yeah. So, I think 2 more minutes. So we can start. Thanks a lot. Today I'm going to deliver a very introduction talk to coroutines, especially concerning about why do we need these coroutines. So everyone is talking about them, that we have it now, but what's the matter? What do coroutines bring to the table? The first, for those of you who, haven't heard about Kotlin, still, there might be some. So there is the Kotlin programming language. It was the first release was last year, February last year. This year we released the version 1.1. And now Kotlin is used inside JetBrains for internal products, not connected with Android, and in some other companies. And as for statistics, 50% of the usages is about Android, and the others are not about Android. And we wrote the book that is now available, that is finished, covering Kotlin. Actually, it covers the first version. It doesn't cover coroutines yet, because coroutines was released and later, after we finished the book. So at that time, the coroutines design wasn't ready yet. So my name is Svetlana Isakova, and I'm developer advocate at JetBrains and one of the authors of this book. So let's start our talk, our discussion. Again, what are we going to talk about? Kotlin coroutines. It's the key new feature in this new release, and it brings support of lots of useful features. Actually, it brings support of those features that we have available already in many different other languages. So, for instance, this async await functionality is something that is quite well known already in the C# language. Who has some experience with async await in C#, maybe? Okay, yes, so for you it's very clear what's going on here. And coroutines allows you not only use async await, but some other features as well. So let's start. The term coroutine was actually coined very far ago. It was first invented somewhere in the 60s, and it was used by Donald Knuth in his book, and he opposed coroutines to main routine and subroutines. So for him, coroutines were just independent subprograms that were able to call each other. And today we're going to see how this first idea now is present in the modern language like Kotlin. First, we'll start with some motivation, with async await example. I will show you why do we need this async await at all. After that, we will discuss threads and coroutines. We'll understand what's the different and what does this lightweight thread mean. And last, we'll see some common questions. Async await. The first example is very simple. So there is a very simple code. It's just loading an image, and there is question what's wrong with it. So it looks very, very simple, very straightforward. However, the problem for you should be just obvious that this operation of loading image might be very time-consuming, and there is a possibility of blocking thread here. So in Android will not allow you to do this at all, but if you do, you can. So if you do something like this long operation in the UI thread in Android, you will block your application, and that's not good. So there is a general problem, and there exists general solution to this problem. What we do now, we can define callback that is called after the operation is complete. So even if it's a Rx or something, there are still all these callbacks that you define what to do after it completes. So there is one solution. And coroutines, in essence, suggest you another solution to the same problem. The coroutines says, okay, now we have time-consuming operation, now we have this callback, but let's rewrite it as before. Let's rewrite it in an imperative style. So coroutines allow you to write the code similar to the one that we had at the first slide, at the first example. Just without defining the callbacks, you just write your code sequentially, but you use some special syntax like async await. So again, there is the whole point. So the whole point of the coroutines is this: allow you to write sequential code instead of using callbacks and defining the callbacks. So this actually is the example that explains everything, that shows you why do we have these coroutines at all. And through the rest of the talk, we will discuss how it's actually implemented, how it works, and why is it so important. So the goal is this one: just being able to write very simple code as before, but without blocking threads. This feature of async await was available for quite a while already, and you can use this feature in C# language, as I mentioned before. And in C#, async and await are keywords built in language syntax. So in C# you can define, for instance, this asynchronous function, asynchronous computation, and after that you can await it. And you can compare that in Kotlin it looks very similar to what C# has. However, there is a difference. In Kotlin, all these async and await are not functions, are not built-in language constructs, but functions. So in Kotlin, async and await are functions defined in the standard library. You can think of it as follows. In the language itself provides the support for coroutines. And on top of it, you can build lots of useful libraries implementing well-known patterns like async await. So here, coroutines lives under the hood in the language, and async await are just functions. Okay, now let's move on and look at the comparing between threads and coroutines. So there is a well-known phrase that coroutine is a lightweight thread, so it's written in the documentation. But what does it actually mean? So let's start. How do we do asynchronous computations now? At first, how can we do it? And actually, how did we do it some time ago? The first very naive solution would be to start a new thread for every computation. So when you have like different computations to to do, you can at first use the separate thread for each one. There is my notation here. The line will express the thread, and this block will express the computation that we want to do. And this approach is too expensive. So now we do not do like this because threads are expensive. The thread needs something around from 1 to 2 megabytes of memory, so you just cannot start too many of them. And corresponding to it, coroutines are cheap, but we'll see. So this solution doesn't work for us. So what else can we do? In Java 6 or 7, there was executable introduced, and the idea is the following. You define several threads. So you define executor that knows about several threads that are available in the memories. So it operates these threads. And you just give this executor the tasks, the computations. So here you now can compute, you can do several computations on the same thread. However, with this approach, with the executor introduced in Java 6 and 7, there were some problems because it was very difficult to manage dependencies. If you want to say that, okay, this computation should go after the first one, it is too hard to do this. With RxJava and with completable features, it's much easier, but still there is like how the things work. So now we have we see this idea of coroutine, and that means actually the lightweight thread. And for us, it's convenient to think about this as a computation that can be suspended. So on our picture, it looks like this. So you can have your computation operating on some thread, and by the compiler support, by Kotlin supports suspending of this computation. So it really looks like this. You start computation on a thread, then you just put it aside, and when you're ready, you can continue this computation of the thread. So this is the general idea of what a coroutine is. It's just a suspendable computation that can be called on, that can be run somewhere. Okay, so now we see the feature actually introduced in the Kotlin language itself. It's suspend functions, and suspend fun, if you see somewhere this suspend fun, that means that this function defines a computation that can be suspended, so that can be somehow put aside somewhere else. Why it's important? Why it is so important, these suspend functions? So we know that, what was the problem with our first approach? Without callbacks, without RxJava, without completable features, when we just wrote sequential code on the thread. The problem was that while we started, for instance, these two separate activities from the first one, and we are trying to wait until they are finished, we are blocking the thread. So when we are in an Android environment, for instance, if we just block UI thread, that's terrible because the whole application blocking. If we are just in general, somewhere in Java system, and we have a pool of threads, it's still expensive to waste a thread on every operation because there can be the huge amount of operations, and it would be too expensive to spread the thread on it. But otherwise, if the threads were lightweight, if the threads were not as expensive, if they were cheap, that the solution would work. When we are calling about completable features or RxJava, what it gives us the ability to define dependencies and to say, okay, please start these two actions, and after they complete, complete this computation. And to achieve this, you have to split your whole process into the start part and into the callback. That should be done after your action finishes. And now this second blue block is expressing the callback that is started afterwards. And when we have coroutines, what is, in essence, what's the idea? Is that you can write your code like you wrote it in threads when you blocked threads, the first example. But now, instead of blocking thread, you suspend the computation. So now you start these two green and red activities, not activities, but computations. And then, instead of blocking the thread, you can put the first computation aside and return it when these two new computations are finished. And now that actually means why it's important that computation can be suspended. It allows you to write the code as you wrote before with threads. And now thread is not blocking. So now thread is free and can be used to do other computations or can be used to respond to the client requests. So let's go back to the image example and see how it's expressed in the code, in the Kotlin code. So here we have this await function, and this await call is actually suspending call. It actually what puts this computation aside, what suspends it. We can see that actually async under the hood returns an interface defined in the Kotlin library. It's here it's default interface, but actually it can be anything. So we have different functions. So it can be completable feature as well if you have Java 8. And inside this default interface, there is the function await is declared as suspend function. So here you see the suspend keyword with await, and that means that await is something that can put your computation aside. So again, await suspends computation. How does it work? There is this process image computation that starts another one, load image, and at the moment when process image reaches this await call, that means that the compiler puts this process image computation somewhere in the second picture, puts it aside. And when it's ready, it continues. When the result of load image is ready, it just takes it from this somewhere and returns it to the thread and continues the computation from the point when it was suspended. And it's important that when you suspend the computation, all state of your all local variables is stored, and all the callback is stored. So you continue from exactly the same point when you suspended. And all of this is implemented by the Kotlin compiler. There is a question: on which thread do we continue our computation? Because you see here, we can continue on the same thread or on the other thread, and actually the answer is, it depends, and you specify that when you call the thread. And here, I have to admit, I, to some extent, lied in the previous slides, because at least in the current design, you can't call a sync function without these parameters specifying where you want to start your new coroutine. And here for instance, here you can specify that please start new coroutine in the command pool. Command pool is actually a wrapper around a fork join pool, so you just has several threads and can manipulate different computations, different executions on these threads. So in this case, the computation can be continued. It can be started in any thread from the pool. You can specify, there's actually launch is another function that just async starts a new computation, and async returns you the result, and launch just starts the computation that doesn't return the result. But actually, it does absolutely the same. And this syntax allows you to start your new computation, your new coroutine in the UI thread. And when it's suspended like this, like the blue one, it was suspended because we called, for instance, a wait function. And after that, when you continue it, this context guarantees you that this computation will be continued in the UI thread. So you see, while this blue computation was suspended, something else might have happened on the UI thread. So another red computation might have been executed on it. So it's not blocked. And when the result is ready, you can return your computation again back to the UI thread. You can also provide your own custom executor by defining a special coroutine context and pass it as a parameter to these functions. Suspension might actually not happen if the result is already available. So in this case, you start this load image computation somewhere in the other thread, and you can do other work while this grand computation is going. And when this process image reaches this await, the compiler checks, okay, is the result available already? It can be. If it's available, then the computation can be continued directly on the thread. So it may actually not be suspended if your computation is fast enough. Let's look now how looks the example of this starting two computations, two asynchronous computations at the same time. And here there is an example of image overlay. And we see how we see explicitly where we start all these new computations. So, for instance, we have loading two images. For simplicity, it's red and green. And we define the function that asynchronously loading these two images. And when both of them are ready, you can overlay them. So here you define that this computation should be started in the common pool. And after that, you write two await functions. Each await awaits the corresponding computation and continues the suspended one after it finished. How do we call it? For instance, here below, we have we can say that we want to process all of this on click. So we launch the computation on UI thread. We specify, okay, we want to do the following on the UI thread. And here in this computation, we start asynchronously this overlaying that starts asynchronously all the loading. And after that, when it's ready, we show the image. And you see that this show the image will be computed in UI thread. And that's how this code looks like with coroutines. It's rather straightforward, it's sequential, but still it does all the computations somewhere in background asynchronously. Now let's go to some common questions about coroutines and how some of things work. The first one is, what about handling errors or exceptions? And actually, await rethrows the exception. So you can use a regular try catch to manipulate these exceptions. So here there is an example. You start the green computation asynchronously in the command pool, and somehow during this computation, my exception is thrown. However, you see that you can just write regular try catch, and inside it use task await, and you can catch this exception. So under the hood, await catches this exception and rethrow this. So you see that you throw this exception on one thread, but catch it on the other thread. it might happen, because you catch it in the first coroutine when it's continued. Another question: can you define actually your own custom suspend functions? And the answer is yes. And there is important thing that, for instance, in C#, all this asyncRx feature, you used it when you write asynchronous computation. This asynchronous function should always return you a task, something like a future, something that deferred, and you must explicitly await for the result. However, in Kotlin, the style of this asynchronous programming is a bit different, because now you not only is able to write these async functions that return something deferred, but you can also define your own suspend functions. And every suspend function actually means that it is a computation that can be suspended. It is a computation that can be put away somewhere and then restored and continued. So, for instance, here you can have several suspend functions that somehow can be blocked during the process. Not blocked, now new word, suspended. And if it's suspended, you do not block the thread. Your computation just put aside and then continued. And when you define your own custom logic, now you can manipulate all these suspend functions. So you can define new suspend function that calls all the previous suspend functions. So for instance, in this example, we want to show user info. We want to first load the login for our user. So it can be suspended somehow because, I don't know, it's network operation or something. After that, separately, we have to load user data. We do it again in a suspend function. In this case, these two first calls are processed one after another, but actually it makes sense because the second load user data uses the result from the first computation, so you have to do that. After that, you can say, okay, I want to load user image asynchronously. So you have this load image suspend function, and you can define the context where you launch it. In this case, you launch it in this command pool. So you say async command pool, then load image. And after that, you launch in UI thread actually the code that sets the data, that shows the data to the user. And you can see that this code looks very sequential. But what happens under the hood is your image is loading asynchronously. So you show the user data before image is loaded. So the actual suspension happens here in launch UI thread. So you show data, and when your computation reaches a wait, it can be suspended. So it shows user data, then it can wait while the image is loaded, and after that show the image. So this code looks very easy, straightforward, sequential. However, some magic is hidden. This suspension magic. Where can you call a suspend function? So you can define one, and how do you call it? And actually, you can call suspend function inside another suspend function. So that means that, okay, this one, this is the small part that can suspend computation. That is the bigger part that suspend computation. So we saw it in the previous example. If you try to call, for instance, login or load user data that are suspend functions, you have to make the upper function suspend. Or the other case, you can call it inside these special library functions that we saw so far, like async and launch. But actually, under the hood, they are declared that they take some other built-in thing as a parameter, suspend lambda. So if we look at declaration of this log and this launch and async functions, we'll see that they take suspend lambda as a parameter, and actually this another place general place where you can call suspend functions. So now you can program in terms of these suspend functions, and you can call them in these special suspend contexts. High probability that you will write lots of your suspend functions, but probably not a lot of these functions that take suspend lambdas as arguments, because here there is just built-in library constructs that contain all the hidden magic under the hood. So in the implementation of this launch and async function, some you can go there, navigate to the declaration and see that in the end, they call some built-in primitives that actually suspends the computation. So some magic is hidden here, but for you, it's just the library function. And if you really want to provide a better API for your library, you can define something similar. Some implementation details. At first, there is a question. Is it possible to call suspend functions from Java, for instance? And the short answer is probably not, because how these suspend functions are implemented, every suspend function takes one extra parameter, one extra argument, which is hidden. And the parameter that defines what actually is happening, where to continue and what to continue. So here, when you define in Kotlin suspend fun foo, in fact, in the bytecode level, it takes one extra parameter. And that means that it's quite inconvenient to call it from Java because you have to provide your own continuation. In theory, it's possible, but it's better not to do that. What to do if you want to call your foo function from Java? It's very simple. You just define another one, async version, that returns your regular feature that you use from Java. So you define the one nearby, and this one you can call from Java in your regular style using the features or XORs or everything. Under the hood, Coroutine body is compiled to state machine, so it's convenient to think about this it like this. So you have the first coroutine, and it can be suspended. So when we suspend it, we put it away, and it will be the first state on which it's first state on which it's suspended. Then we return it. Then the second await function or another suspend function suspends it, and it's the second state. And actually, this explains why coroutines are so cheap. So at first, I told you that the threads are very expensive. Each thread requires lots of memory. In comparison, coroutines are very cheap. And actually, only one object is created for each coroutine that stores somewhere in the memory that stores this state machine describing the states, how to suspend and how to continue the coroutine. I think I have some time, so I will show you another topic first. Another common question, is it possible to cancel the coroutine? So that's another question that may arise in your mind while you listen to it. And the question to it is yes, if your coroutine is cancelable. So that means that if your coroutine does some computation and is busy doing this computation and the thread is busy, then you have to check explicitly whether your coroutine was cancelled or not. So if you don't do that, then your coroutine won't notice that it was cancelled. So it's your responsibility. It's the same with thread, actually. So you can cancel it, like here, job, you can just say job cancel because some other information arises. But if your computation is just, if your coroutine is just doing some computation, you have to check explicitly. However, if your coroutine calls some library functions like delay or await, then these functions check for cancellation for you. So if your function just sometimes awaits, when it is awaited, it checks if it's cancelled, then your coroutine will be cancelled. One more thing, if you want, you can start your coroutine in a special non-cancelable context. And in this case, just nothing happens. So that was my small diversion, and we return to our routine. So that was all I wanted to share with you about coroutines in general, and about async await functions and why they are important. Actually, coroutines allow you not only implement async await, but some other famous, well-known patterns as well. For instance, there is yield. In Kotlin, it's again function. It's another topic that is not at all connected with asynchronous programming. It's just generators that allow you to generate lazily your data. It's a very convenient feature, and it is used already in different languages. And in C#, again, it's a keyword. So yield is a keyword. But in Kotlin, yield is a function defined on the top of this coroutines support. So what's the example? Here we can build a sequence and yield all the elements. You can yield sequence, you can yield range, you can yield whatever, you can yield indefinitely, and the actual yielding happens only when you require for that. So here below, we iterate over sequence, and you see the output, and you can see the output that at first, the first loading happens only when you request for it. So when you iterate over it, before processing the first one, it is loaded. And the second is loaded only after the first is processed. So that means that if you don't ask for the element, it won't be loaded, won't be gathered for you. Yeah, so this is a more complicated version of the picture that we had in the very beginning. So the general idea is that Kotlin brings to the table the support for coroutines, and it's a well-known term, and it is something built in the language. So the actual support is the suspend functions, suspend lambdas, generating state machines, and providing the ability to put away the computation. And all the necessary functions that you use as an application developer are defined in the libraries. So there is a library for async await. Actually, there is one, Kotlin Coroutines, that contains async await and much more. It actually defines channels like in Go. It defines lightweight actors. And also you can build yield on top of this, on top of the coroutines. Yield is supported in the standard library itself, not in this separate library, but that's a small detail. So yes, that's the general picture, and I want, my goal is to motivate you to go and read more about coroutines. There is the repository that contains all the library, defines all these functions, async await and others, and there is an amazing guide written for the start. And all of this, I want to mention, is done by a guy called Roman Elizarov. So if you want more deeper talks about how coroutines are implemented under the hood, just, I think for now they are not available yet, but I know that he's going to record them, so you just can find, you know now what person to find. So yeah, there is the guide, and here's Roman Elizarov, And he actually joined the team in autumn, and after that he wrote this support for coroutines in the library. And here is the guide. Read it first, and it has lots of examples that you can. So it's step-by-step guide that that you can read to learn how they work. Yeah, there's the guide, and I think that's all. So thank you very much, and have a nice Kotlin. So now we have
time for questions. I have a mic. We have 2 mics actually.
Hi there. It seems that Kotlin can have useful features indeed. So in terms of the coroutines, it got my attention. My question is regarding the how does it actually expand on the Android? So possibly I have just spotted how does it work. Perhaps because you can specify the thread, UI or non-UI thread. So it seems that it does require some additional implementation of how to actually do the UI doing things on Android, right?
But on Android, you just can, without any coroutines, you can just run on UI thread. So under the hood, this context uses the Android library.
Aha. So you don't need any additional code to instruct Kotlin that.
No, you have to add Kotlin coroutines library for general library, and there is like a very tiny piece that defines this UI context that actually depends on Android, so you have to add it as well.
Okay, so then after I have added these libraries, I'm good to go, right?
Yeah.
Oh, that's great.
Yeah, and you need this Kotlin 1.1 version, so the latest one that supports coroutines.
Okay, thanks. How stable is that?
For now, it's in experimental mode, so that means that you can use it, but there is no backward compatibility guarantee so far, because actually for this moment we want to gather as much feedback as we can. So we want to. So actually, almost everything is ready for now, so we can release it maybe very soon. But now we want to motivate you to try it and to report us back whether how it's going. So maybe some changes will be. But there is a procedure of how to. So you can start using it, and there is a procedure how to switch to the released version when it will be released. So you can read it. It's also quite easy. So in JetBrains, we try to. If you tried Kotlin, especially before our first release, you might know that we try very hard to provide very easy like going to the next version. So we try to make this experience as simple as possible.
Okay, great, thanks.
Hi.
Hello. I have a question regarding Java support, because Kotlin was so far known for its interoperability with Java, and you mentioned...
Say it again? Known?
Kotlin was known for interoperability with Java. So, and you mentioned that coroutines in terms of suspend functions are not recommended to be called from Java?
No, I gave you how to do this. So when you call, so you do not call the suspend function directly. But in Kotlin, you write another function nearby this short one that just wraps the result in the future on the default, and you return it to Java easily. So if you want to call the function from Java, you have to declare a separate one consisting of one line, and you call this for async instead.
Okay, thanks.
Yeah, so that's the idea. So in Kotlin, you manipulate all these suspend functions, and in Java, to call this for Java, you want something else, maybe.
Hi. Over here. Sorry.
Hi, yeah.
I have a question. I was wondering, how do you test a function which contains a coroutine? What happens under? Is it still async
You can define the special run blocking. So when you mix this asynchronous context and then in general, you just want a place where it is blocking. So you can just wait from your main function, for instance, or for your test function for the coroutine, for the top-level coroutine, blocking the thread.
So would I have to add something for the tests?
No, it's for now you have to write this run blocking. I'll show you in the, I think in the guide. It should be here. It's everywhere. So here there is a run blocking function, and that means that's how you can call it. That's how you can start these asynchronous coroutines from the thread, and just here there is join. The join function will wait in a blocking way. Not in a blocking way. This run blocking allows you to wait in a blocking way in your thread. And there is now a plan to provide maybe some annotation or something else to simplify this, but for now you just write your function, and for every function you say like equals run blocking, etc. Yeah.
Okay, thank you.
So my question would be about the future of Kotlin. What kind of
magnificent. We will conquer the world. Yes.
So, about what language features are you planning, and whether you're planning to extend it to other platforms like, I don't know, native?
JavaScript, native, yes, we already released. We have, I'm sorry, this Java conference, so I'm talking mainly about Java, but in Kotlin 1.1 we released finally JavaScript support, so you now can compile Kotlin to JavaScript. And recently we started in YAP mode native platform, so we can compile Kotlin to the native platform as well. So now it's in progress, but you can try it if you want, if you're ready.
Okay, and language features, what are you planning next?
Language features, the nearest release is focused mostly on the performance. So like 1.2 will happen, I hope soon. It's very hard to from Kotlin point of view, it's very hard always to say like when the release will be. So like soon, and it will be focused on performance. And after that, there is a list of different features with different priorities, and we actually did some survey recently. About what features do you want the most from Kotlin point of view. I can remember only, I think, some conversion for Kotlin types and some others. So there is actually the list of features that is planned, something like people want more.
And one more, what is Kotlin written in? Is it
for now, Java and Kotlin. So at some point, several years ago, we switched to Kotlin. I was still on the team there at that time, and now we haven't switched to Kotlin at full because it's the process that's constantly going. Someone asked like, does anyone mind if I switch, if I convert this class to Kotlin? But now we have a great chance to test the interoperability with Java. When we have Kotlin compiler written in Java and Kotlin, we can ourselves see what works and what doesn't work.
Thank you.
Thanks.